In 1940, a 57-year-old Mormon mayor drove a 21-foot-long aircraft-engined monster across the Bonneville Salt Flats for 24 straight hours, alone, averaging 161 miles per hour. That record stood for half a century. Ford tried to beat it, Mercedes tried, Audi tried, they all failed. And then 8 guys with a barely modified Corvette and a couple of Samsonite suitcases full of spare parts showed up in West Texas and did what none of them could. So, let's talk about what was happening in the late 1980s. Chevrolet had a problem. The Corvette was America's sports car, had been since 1953, but by the mid-80s, the car had lost its edge. The C4 generation that arrived in '84 was a good car, a solid car, but it wasn't scaring anyone in Stuttgart or Maranello. The base engine made 245 horsepower. For reference, a Ferrari Testarossa was putting out 390. A Lamborghini Countach, 455. The Corvette was in a different zip code. Meanwhile, the Japanese were getting aggressive. Honda and Toyota were rumored to be developing supercars. Lloyd Roos, the head of Chevrolet Pontiac Canada Group at GM, was worried. If the Japanese built something that stole the Corvette's thunder, that was an existential threat to one of GM's most iconic nameplates. Corvette chief engineer Dave McClellan had the same fear. He wanted to build a supervet, something that could legitimately compete with the best Europe had to offer. The problem was that GM's own powertrain division didn't have the technology to get there. They considered a turbocharged V6. Nobody wanted a 6-cylinder Corvette. They looked at twin-turbo small blocks. Emissions regulations killed that idea. The transmissions couldn't handle the torque anyway. So McClellan did something that would have been unthinkable a decade earlier. He went to the British. In 1986, General Motors had acquired Group Lotus, the legendary British engineering firm with Formula One pedigree, going back to the 1960s. Jim Clark, Graham Hill, World Championships won with Lotus Power. These were not people who made grocery getters. McClellan approached Lotus with a simple pitch: help us build the fastest production car in the world. Lotus engineer Tony Rudd listened to what Chevrolet wanted and came back with a counter-proposal. Chevrolet's original idea was modest: just design new cylinder heads for the existing L98 engine. Rudd looked at that plan and said, no. If you want the fastest production car, you don't modify an existing motor. You start from scratch. He suggested building an entirely new engine. GM, to their credit, agreed. And the LT5 was born. Development started in 1986 at Lotus's facility in Hethel, England. Now here's where this story gets interesting. The engine Lotus designed was unlike anything Chevrolet had ever put in a car. An all-aluminum 5.7-liter V8 with 4 overhead cams and 32 valves. Forged crankshaft, lightweight pistons and connecting rods, a compression ratio of 11:1. Output was 375 horsepower at 6,000 RPM and 370 pound-feet of torque. That put it within spitting distance of a Ferrari Testarossa from a Corvette. But the really clever bit was the air management system. Lotus designed a 2-stage induction setup with 3 throttle bodies. At low throttle, only 8 of the 16 intake runners were active. This made the car perfectly civilized in traffic, smooth, quiet, almost docile. Open it up, and all 16 runners kicked in. The transformation was dramatic. The thing is, nobody at Chevrolet could actually build this engine. The tolerances were too tight. The aluminum casting work was too specialized. The Corvette plant in Bowling Green, Kentucky couldn't handle it. No GM production facility could. So they contracted a boat engine company, Mercury Marine's Mercruiser division in Stillwater, Oklahoma, a company that normally built high-performance marine engines. They had the expertise in precision aluminum work that this motor demanded. Each LT5 was essentially hand-assembled. Mercury's technicians could build 18 per day. Every single one was dyno-tested before shipping. The engine was designed in England by Formula One engineers and hand-built in Oklahoma by boat engine specialists. For a Chevrolet. You can't make this up. And there was an interesting side effect inside GM. When word got out that Corvette engineering had gone outside the company for the ZR-1's engine, GM powertrain engineers were furious. They immediately started work on what would become the LT1 engine, eventually leading to the LS family that defined American performance for the next 3 decades. The LT5 embarrassed GM into building better engines. Competition works, even when it's internal. The car that received this engine was designated the ZR-1. Internally, they called it King of the Hill. It debuted at the 1989 Geneva Motor Show with a sticker price of $58,995. That was $27,000 more than a standard Corvette. Buyers lined up to pay over $80,000. From the outside, the ZR-1 looked almost identical to a regular Corvette. Wider rear haunches to accommodate 315mm rear tires. A convex rear fascia. That was about it. This wasn't a car that needed a wing to tell you it was fast. But here's the thing about building a fast car. Anyone with enough money can make something go fast in a straight line for a quarter mile. The real question is whether it can do it for 1,000 miles, or 5,000, or 24 straight hours. That question is what brings us to Peter Mills. Mills was a West Coast automotive PR representative, and in the summer of 1989, he had a conversation with Stu Hayner, a well-known endurance racer who'd won the 1988 Drivers' Championship in the Corvette Challenge Series. During their talk, Mills mentioned something that an IMSA GTP Porsche team had told him. Their 962 race cars, they said, didn't have the durability to break Ab Jenkins' 50-year-old 24-hour record. Purpose-built, million-dollar Porsche race cars. And they said they couldn't do it. That admission hit Hayner like a lightning bolt. If the best Porsche had to offer couldn't outlast a record set by a car from 1940, maybe the ZR-1 could. The Corvette was, after all, a production car designed to be driven every day. It was built to last. Hayner called John Heinricy, the manager of Corvette development at GM, and a serious endurance racer himself. Heinricy was immediately interested. He took the idea to Dave McClellan, who gave the green light. Nobody took it any higher than that. As Heinricy later put it, if you take it higher, somebody's just going to say no. Tommy Morrison was brought on board next. Morrison was a race team owner and driver who'd been racing Corvettes since 1962. He'd been kicking around the same idea independently, even discussing it with GM engineer Jim Miniker. Morrison would prepare the cars and marshal the entire operation through Morrison Motorsports. Sponsors lined up quickly: Mobil Oil, EDS Goodyear. Morrison assembled his team, 8 drivers total: Heinricy, Hayner, Morrison himself, Scott Lagasse, a Corvette Challenge racer, Jim Miniker and Scott Allman, both GM engineers, Don Knowles and Kim Baker, both showroom stock racers. Every one of them had serious seat time in Corvettes. Every one of them knew what they were signing up for. Now, let's talk about what they were trying to beat. Ab Jenkins' Mormon Meteor III was a purpose-built, 21-foot-long streamliner designed by Augie Duesenberg. Yes, that Duesenberg. The car weighed about 4,800 pounds and was powered by a Curtiss Conqueror aircraft engine, a 1,570 cubic inch V12, making around 750 horsepower. The body was offset 6 inches to the left on the frame to help it turn on the circular courses at Bonneville. It carried 112 gallons of fuel, which at speed would be nearly gone in about 2 hours. Jenkins had driven it solo across the Bonneville Salt Flats in August of 1940 and averaged 161.18 miles per hour over 24 hours, covering 3,868 miles. Solo, no relief driver. 24 hours behind the wheel of an aircraft-engined monster at 160-plus miles per hour. He was 57 years old at the time and was simultaneously serving as mayor of Salt Lake City, elected without spending a dime on campaigning or giving a single speech. His 1-hour mark during that run was 182.51 miles per hour. The man was a different breed. Ford tried to break that record in '69 with a Mustang. Failed. Mercedes attempted it in '77 with their experimental C111. Failed. Audi threw their hat in the ring in '88. Failed. For 50 years, the record just sat there, mocking everyone who tried. The ZR-1 that Morrison prepared was, well, it was basically stock. That's the part that makes this story almost absurd. Under FIA rules, the car had to remain fundamentally production spec. The modifications were minimal. They installed a 48-gallon fuel cell, which meant removing the rear anti-sway bar to make room. They swapped the stock 3.54 rear gears for 3.07 gears to lower the RPM at sustained high speed. They added extra oil coolers and differential coolers, replaced the headlights with Hella racing lights, lowered the front end slightly. A full roll cage went in, and that was essentially it. The engine was untouched. Stock LT5. No modifications. Oh, and FIA rules required one more thing. The car had to carry non-consumable spare parts in case of a breakdown because any repairs had to be made by the driver, trackside, using only what was in the car. So they strapped 2 Samsonite suitcases full of tools and spare parts to the rear roll bar supports. 300 extra pounds in a car that was already 200 pounds heavier than a standard Corvette because of the LT5 and wider bodywork. The venue was the Bridgestone Tire Proving Ground near Fort Stockton, Texas, a 7.712-mile oval with 1.5-mile straights and 2.35-mile curves banked at 7 degrees. Morrison chose it specifically because the gentle banking wouldn't overload the stock suspension. Other options had been considered and rejected. Daytona and Talladega had too much banking for the stock suspension. Nissan had a track in Arizona, but wasn't keen on a Corvette setting records at their facility. GM's own proving ground raised safety concerns. The Fort Stockton track had one significant problem: no fences. The facility was in rural West Texas, surrounded by open desert, deer, coyotes, javelinas. At 190 miles per hour, hitting a 50-pound coyote wouldn't just damage the car, it could kill the driver. The track also had no retaining walls. If a driver lost it in the banking, the car would fly over the edge, sail 375 feet through the air, and crash into the desert. Help could be 10 minutes away. Their solution for the wildlife problem was characteristically straightforward. 7 pairs of men in trucks, spaced about a mile apart around the outside of the track, driving around the perimeter, firing shotguns into the air all night. If you're enjoying this, hit subscribe. We cover stuff like this every week. Okay, back to it. The morning of March 1st, 1990 was cold. 35 degrees with light snow showers. Not ideal. Morrison figured temperatures would climb through the afternoon. 2 cars would run simultaneously. The ZR-1 going after the 24-hour record and the 5,000-kilometer and 5,000-mile marks. A stock L98 Corvette. The base model, making about 350 horsepower with some exhaust modifications, would chase the 6-hour record and shorter distance marks. At 9:56 a.m., both cars left the starting line. Heinricy was behind the wheel of the ZR-1. Morrison drove the L98. The plan was simple. Each driver would do 80-minute stints, foot to the floor the entire time. 7+ miles per lap, no lifting. The pace was brutal from the start. Heinricy later described it plainly. Speed was in the low 190s. They didn't lift in the turns. They entered them foot on the floor, and by the time they came out, Speed had dropped to the high 170s. It didn't slow down much in the turns, for 80 minutes straight. Then you got out, rested, and did it again. Turn 3 was the worst. Coming off the back straight, the ZR-1 was running downwind at 188 to 192 miles per hour. The car weighed over 3,700 pounds with driver, fuel, and those suitcases. The suspension was stock. The tires were production Goodyears. And you just held your foot down and trusted the engineering. This type of driving puts more stress on a human body than any race. In a normal endurance race, there are corners, braking zones, slow sections where your body and mind get brief moments of recovery. Here, there was nothing, just constant, unrelenting speed. The vibration alone was exhausting. The concentration required to hold a line at 190 miles per hour on a track with no walls in a production car for 80 minutes was mentally crushing. After dark, it got worse. Despite the brightest hella lights money could buy, the drivers were constantly overdriving their headlights. They could see maybe a few hundred yards ahead. At 190 miles per hour, that's less than 4 seconds of reaction time. And somewhere out there in the darkness, there might be a coyote standing on the track, or a deer, or a javelina. If the car left the track surface, there was nothing to stop it. No walls, no barriers, just desert scrub and darkness. The Fort Stockton Fire and Rescue Squad stood by the entire time, but everyone understood that if a car went off the banking at speed, it would fly hundreds of feet into the West Texas wildlands. Finding the wreckage in the dark would take time. Finding the driver alive would take luck. One crew member put it simply, "This record stuff is a challenge in daylight, but at night it's damn scary." The L-98 did its job beautifully. By the 6-hour mark, it had conquered the 100, 500, and 1,000-kilometer records, plus the 1-hour and 6-hour marks. 5 FIA records in 6 hours from a base model Corvette. Then it was pulled off the track and loaded onto a truck. It had to be shipped to the Geneva Auto Show, that's right. They yanked a record-setting car off the track mid-event to put it on display in Switzerland. Priorities. Meanwhile, the ZR-1 just kept going, hour after hour. Driver change after driver change. Fuel stops took roughly 45 seconds to fill the 48-gallon cell. The drivers rotated through their 80-minute stints with mechanical precision. Get in, belt up, foot down, hold the line, get out, rest, do it again. The LT5 ran at 5,500 RPM continuously. The transmission shifted smoothly. The differential stayed cool. Nothing broke, nothing overheated, nothing even complained. The engine that was designed in England and hand-built in Oklahoma by boat engine specialists was doing exactly what it was engineered to do. It just refused to quit. Now let's talk about what was happening under the hood during those 24 hours, because the engineering is what makes this story remarkable rather than just brave. The LT5 was running at 5,500 RPM non-stop. At that speed, the pistons were traveling up and down the cylinders roughly 4,500 times per minute. Over 24 hours, that's roughly 390 million piston cycles, each one generating combustion temperatures north of 2,000 degrees Fahrenheit, in a production engine with no special preparation. The all-aluminum construction was critical here. Aluminum dissipates heat roughly 3 times faster than cast iron. The Nikasil-coated cylinder liners provided a surface harder and more wear-resistant than traditional iron sleeves while maintaining the thermal advantage. The forged crankshaft handled the continuous rotational stress without flex or fatigue. The dry-sump lubrication system kept oil pressure consistent even under sustained high-G loads through the banked turns, preventing the oil starvation that would have killed a conventional wet-sump engine within hours. The 32-valve, 4-cam configuration wasn't just about making peak power. At sustained high RPM, The additional valve area reduced pumping losses, meaning the engine didn't have to work as hard to breathe. Less mechanical stress per power stroke, less heat buildup per cycle. And the air management system, the one designed to make the car civilized in traffic, played an unexpected role. With all 16 intake runners open at full throttle, the tune-length runners provided a ram air effect that improved volumetric efficiency at high RPM. The three-throttle body design distributed airflow more evenly across all 8 cylinders than a single large throttle body could, reducing cylinder-to-cylinder temperature variations that cause hot spots and eventual failure. The ZF6-speed manual transmission was another unsung hero. It was essentially a racing gearbox. ZF had been building transmissions for Porsche and other European manufacturers for decades. The unit in the ZR-1 was built to handle 500 pound-feet of torque. The LT5 only made 370. That 74% load factor meant the transmission was loafing. 24 hours of sustained operation was well within its design envelope. The Bilstein-engineered FX3 suspension was derived from technology developed for the Porsche 959. Gas-over-oil shock absorbers with adjustable orifices controlled by servomotors. 14 damping steps across 3 driving modes. For the record run, it was locked in its firmest configuration, providing consistent handling, even as tire wear changed the car's balance over thousands of miles. The cooling system was perhaps the most critical component that didn't fail. The extra oil coolers and differential coolers Morrison's team added were the difference between success and catastrophe. At sustained speed, the aerodynamic drag alone was generating enormous heat in the drivetrain. The stock cooling system would have been marginal. The additions gave just enough margin. For comparison, the Porsche 962 was one of the most successful endurance race cars ever built. Multiple Le Mans wins. But even Porsche's own team admitted it couldn't sustain the speeds needed for 24 continuous hours at record pace. Race cars are optimized for bursts of performance with planned pit stops. The ZR-1 was a production car optimized for exactly the kind of sustained, unchanging stress that kills race cars. Dawn on March 2nd brought clear weather. The ZR-1 was running flawlessly. The team could feel it. They were going to make it. Just before 10 a.m., 24 hours and 4 minutes after the start, the ZR-1 crossed the mark. The record that had stood for 50 years was gone. The numbers were staggering. 24-hour average speed of 175.885 miles per hour, including pit stops. For fuel, driver changes, everything. That was nearly 15 miles per hour faster than Ab Jenkins' record, 4,221.256 miles covered, and they did it in a car you could buy at a Chevy dealer. But the team wasn't done. The car was running perfectly. Why stop? They pushed on toward the 5,000-mile mark. 4 more hours of running. And then, with just 8 laps to go, the only mechanical failure of the entire attempt occurred. Stu Hayner, driving the final stint, noticed the engine temperature climbing rapidly. A coolant hose had been chafing against the fan shroud for almost 29 hours, and finally wore through. Heinricy described his reaction. Even though he knew they already had the 24-hour record, his first emotion was a huge letdown. They'd worked so hard. To go down now, with 8 laps remaining. Tommy Morrison development crew replaced the hose and added coolant. Hayner went back out with instructions to take the final laps at 140 miles per hour. Easy, don't push it. The ZR-1 crossed the 5,000-mile mark at 28 hours, 46 minutes, and 12.426 seconds. Average speed of 173.791 miles per hour over 5,000 miles. And then Hayner did something that perfectly captures the spirit of this entire endeavor. He unscrewed the throttle stop and did 2 victory laps at full throttle, 15 miles at over 190 miles per hour, after 5,000 miles of hard running. after a coolant leak after nearly 29 hours of continuous operation. The engine didn't care. It just kept pulling. The final tally: 3 outright FIA world speed records, 5,000 kilometers at 175.710 miles per hour, 24 hours at 175.885, 5,000 miles at 173.791, plus 4 additional FIA International class records. From a car that weighed 3,700 pounds, carried 300 pounds of luggage, and used an engine that a boat company built by hand in Oklahoma. The aftermath reshaped how the automotive world viewed the Corvette. Chevrolet ran a full-page ad in Automotive Magazine on June 25, 1990 that read, "In 24 hours, we did what nobody could do for 50 years." The ZR-1 went on a promotional tour as the world speed record Corvette. The entire team signed the underside of the hood, a tradition that turned a factory part into a piece of automotive history. That car now sits in the National Corvette Museum in Bowling Green, Kentucky, where it's been since the museum opened in 1994. You can go see it. The signatures are still there. The record also sent a message to the European manufacturers. Porsche's own endurance racing team had publicly admitted the record was unbeatable, and then a group of Americans beat it with a production car. The psychological impact was probably worth more than any advertising campaign GM could have bought. For Tommy Morrison, the record run launched a decade of Corvette endurance racing. Morrison later built dedicated ZR-1 race cars for IMSA competition, taking on the 24 Hours of Daytona. His number 92 car placed 4th in class at the 91 Daytona 24-hour. One of those cars now resides in the Smithsonian's National Museum of American History, a Corvette, in the Smithsonian. For John Heinricy, the record validated everything the ZR-1 program stood for. He compared it to running 10 Indianapolis 500s back-to-back at 175 miles per hour. His take was characteristically understated. It's not a highlight of your career, it's a highlight of your life. The LT5 engine went on to be produced through 1995. In '93, Lotus updated the design with revised cylinder heads, cam timing, and exhaust, bumping output to 405 horsepower. Just 6,939 ZR-1s were built over the model's 6-year run. The engine was discontinued when GM grew uncomfortable that their flagship Corvette's most critical component was designed overseas and built by a marine engine company. Internal politics killed what many consider the finest naturally aspirated V8 of the 1990s. There was supposed to be a third-generation LT5. Lotus had a 450-horsepower version, nearly complete with new heads, new intake manifold, and heated catalytic converters, fully emissions compliant. They had enough parts to hand-build 20 engines. Then GM pulled the plug. All the prototype parts were thrown away. The Corvette, of course, kept going. The ZR-1 nameplate returned and returned again. Today's C8 ZR-1 makes 1,064 horsepower from a twin-turbocharged flat-plane crank V8 designed and built entirely in-house. It runs the Nürburgring in 6 minutes and 49 seconds. It beats Porsche 911 GT3 RS lap records by 5 seconds at Road America. It costs $174,995. And here's the part that connects directly to 1990. The lap records at 5 major American tracks were all set by GM engineers, not professional racing drivers. Company guys, just like Heinricy and Miniker and Ullman in 1990. The culture that Morrison's team established, the idea that you prove a Corvette's worth by running it hard with your own people, that's still how Chevrolet does business 36 years later. The lineage is direct. But that 1990 record run remains something special. Not because of the speed exactly. Plenty of cars can go 175 miles per hour now. What made it remarkable was the audacity. A Porsche endurance racing team, the best in the world, looked at a 50-year-old record and said it couldn't be done. And a group of Corvette enthusiasts, engineers, and racers, using a production car with a bigger gas tank and some extra coolers, went to a tire company's test track in the middle of nowhere, Texas, hired some guys with shotguns to keep the coyotes away, and broke it by 15 miles per hour. Heinricy said it best. The main reason people buy the car is its image, particularly its racing heritage. I like to do things to promote its image. The Corvette mystique. Morrison put it differently. This was a very sacred thing we set out to do, break a record that's 50 years old. And Hayner, the man who took those final victory laps with a fresh hose and a hot engine, he summarized the whole thing before it even started. We came down here for one purpose, to set a new world record. We knew going in it wasn't going to be easy. No one sets records without taking chances. They took the chances. The LT5 took the punishment. And a car you could drive to the grocery store became the fastest thing on earth for 24 hours. And there you have it. A stock Corvette, a boat engine company, and 2 suitcases full of spare parts versus 50 years of history. If you've ever seen the record car at the National Corvette Museum, or if you think I missed something, drop it in the comments. And if you made it this far, go ahead and subscribe. We do this every week.